Hey math kids, today we're going to be looking at section 4.BD and we're talking about probability and combinatorics. And so we're going to just start talking about combinatorics. So first thing, let's start with these. So this is called 3 factorial. 3 factorial, it's not just an excited 3, but what it means is 3 times 2 times 1. So you start at this number and you multiply by all the natural numbers, down to 1. So 3 times 2 times 1 is 6, so 3 factorial is just 6. By similar thinking, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. This piece would go to 6. This is 20. 6 times 6 is 36 times 20. So that's 720. Okay. Yeah, obviously, feel free to use a calculator if you want to do that. So, and you can just do 6 times 5 times 4. 3, 2, 1, and see, we got 720. Okay, so the reason why we talked about factorials is because we're going to talk about two different things: combinations and permutations. Okay, so combination is when we're looking at, actually let's talk in the context of a combination lock. Now if you do the code 12, 10, 17 and it opens, will the number 17 or the numbers 17, 12, 10 open the lock? The answer is no. Now because the order matters, where this is a different combination than this is actually a permutation. So for permutations, order matters. So if we had a true combination lock, like by the math definition, then if you did 12, 10, 17 and 17, 12, 10, or even 10, 12, 17, or 17, 10, 12, or any combination of those three numbers, then it would open the lock. So these would all be considered the same combination. But because these would be considered different combinations in the real world, mathematically they're actually defined as permutations. And so a common combination lock actually uses permutations instead of combinations. Now I know that's kind of confusing, so let me try to write this one more time. So we're talking about combinations. 2, 3, 1 is the same as 3, 2, 1, 1, 2, 3, etc. Now if we're talking about permutations, 2, 3, 1 is different from 3, 2, 1, and 1, 2, 3. So this would be like 3 permutations, but only 1 combination. Okay. Now, we talked about factorials before. And now you're going to see why. So what we're going to do is NCR, and try not to get too freaked out by this because it actually isn't too bad. Okay, this is a combination formula. These are factorials. And n is like it's the number of possibilities, and then r, like number of things to choose from, and then r is the number of things we're choosing. So if we had like a group of 5 people and we wanted to choose two leaders from those 5 people. And this would be n, and this would be r. And so we'd just plug them in. So we would say 5c2, and then we'd end up with 5 factorial over 2 factorial, 5 minus 2 factorial. Then to simplify that, we start right here. We simplify that first. We get 5 factorial, 2 factorial, 3 factorial. Now you can't multiply these together and get 6 factorial. It's not going to work. So just keep them separate like that. And then at this point I would just write them out. So 5, 4, 3, 2, 1. 2 times 1, and then 3 is 3, 2, 1. Let's see, let's do this. Okay, 3's cancel, 2's cancel, 1's cancel. 2 times 1 is 2, 5 times 4 is 20, 20 divided by 2 is 10. So what this number 10 means is that out of these people, these 5 people, there are 10 ways to choose 2 leaders. Okay? Hopefully that makes sense. Now, permutation works in a similar way. It just has a slightly different equation. So it's just like the combination one, but we actually drop that r factorial that was right here. Okay? And so this would be, we could do the same situation. So 5 people, 2 leaders, but specifically maybe we want a president and then a vice president. So the order would matter, because if we had Tim as president and Jan as vice president, that's a different outcome than saying Jan is president and Tim is VP. So those would be 2 different outcomes in this situation. So that's like when we use a permutation. So this would be 5p2, 5 factorial over 5 minus 2 factorial. So that would be 5 factorial over 3 factorial. And if we write those out, we get 5, 4, 3, 2, 1, 3, 2, 1, multiplied together. Those cancel. 5 times 4 is 20. Now, if we have the same situation, like the 5 and the 2, like we did on both these, the permutation will be the same or larger, most of the time larger, depending on the situation. It will never be smaller. Once again, if you use the same numbers, like a 5 and a 2 with a C and 5 and a 2 with a P, the P is going to be larger. So just kind of keep that in mind as you're doing your homework. Okay. Now there's some homework problems. So the first ones are just using the C and the P like we already did. So I'm not going to do any more of those. But the key to these story problems is figuring out whether order matters or order doesn't matter. So in how many ways can a president, so we have president, treasurer, and secretary be chosen from 5 candidates. Okay, so we have 3 positions and we're choosing 5 candidates. Now, in this, order matters, because if we have the same 3 people but they're in different positions, those would be different outcomes. So order matters. So it's a permutation. So we're going to use our NPR, which was n factorial over n minus r factorial. And then we just plug those in. So we have 5 candidates to choose from, and we're choosing 3. So we say 5 factorial over 5 minus 3 factorial. So that's going to be 5, 4, 3, 2, 1. 5 minus 3 is just 2, so 2 times 1. 2's cancel, 1's cancel. And so now we're going to do 5 times 4, which is 20. And then 20 times 3 is 60. So there are 60 outcomes, possible outcomes for this election. Okay. Let's see. How many ways can 3 students be chosen from a class of 10 students? So in this case, if we choose Billy, Max, and Kendra, that's the same. It doesn't matter what order we picked them in. If we chose Kendra first, Max, or Billy, we still chose those 3 students. And so it's not a separate outcome. So order doesn't matter. And so this is a combination. Since it's a combination, we say NCR, n factorial, r factorial, n minus r factorial. Plug in those. Our n is going to be 10, and our r is going to be 3. So we get 10 factorial over 3 factorial, 10 minus 3 factorial. And I'm going to write these out. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then we have 3, 2, 1 from that. And then 10 minus 3 would be 7 factorial. So we say 7, 6, 5, 4, 3, 2, 1. And cross out 1s, 2, 3, 4, 5, 6, 7. We multiply the bottom, we get 6. Multiply the top, we get 72 times 10, 720. And then we can do on our calculator 720 divided by 6, and that's 120. Okay. If you need additional help, come to Math Lab. Until then, calculator.